Okay, in this one I'm looking at a question that I have had requested for a video going through a concept that we cover in the Unit 1 Maths Methods course. So it's very specific to that course for the Grade 11 Maths Methods. So this is the question that we have that we're looking at, where we have find the value of k if in the expansion of 2 plus kx to the power of 5, the coefficient of x cubed is 1080. Now, commonly you're asked to find the coefficient of a certain term, but in this one we've actually been given this unknown of k and told what the coefficient is. Now, this is related to our Pascal's triangle that we can use for our expansion. So you might have seen this when you were looking at, say, a plus b squared. You'll notice that you get a squared plus 2ab plus b squared when you expand it. So you can see that you've got 1 of your first term, which is your 1 from the triangle, 2 of the second term, 2 from the triangle, and the third one is 1. You'll also notice that your power of a goes down as you go along. So we've got the power of 2, power of 1, and power of 0, and the b's go up. So b to the 0, b to the 1, b to the 2. That's the pattern that we follow with Pascal's triangle. So if we looked at that for the third row, like when we've got a cubic, we could set up that same pattern again. So we would have the first term would be our a cubed, and we would have a coefficient of 1. The second term would have a coefficient of 3, and we would have a squared, because that's gone from 3 to 2, and then we would bring in the b to the power of 1. Then we would have another 3. We would have the a would become 1, because we've got 3, 2, 1. Our b would become to the power of 2, and then we would have on the end a b cubed, and obviously the coefficient of 1. So that's the pattern that we're following. So we're looking at those coefficients in front of those terms there, and we're looking at how the powers of the a go down and the b go up as we do it. So when we see one that we know is a power of 5, we can already know what pattern that should be following. So we would know that the first term is going to be raised to a power of 5. So if we started off this row here, we would know that the second term would be your 5a to the power of 4, and then the b would come in. In this case, our a is equal to 2, and our b is equal to kx. So when we're setting that up, we can follow that pattern as we go along. So the first term would be 2 to the power of 5, because that's our power of 5 up there from our question. Our first part of the bracket is a 2, so it would be raised to the power of 5. The next one, we would get our coefficient from here. If we didn't know that, I'm going to put my little box here and I'll show you how to get that from your calculator. So if you haven't produced the triangle, or you've got one that's looking for a coefficient when you've got a power of, say, 6, 7, 8, 9, 10, you don't want to produce that triangle, I'll show you how to get that number. And then we have our 2 is going to only be to the power of 4, so we've gone down 1, but then we bring in the second part, which is going to be our kx. So it's now come into the equation. So then we have our 2 becomes to the power of 3, so we've gone 5, 4, 3. Our kx is going to be raised to the power of 2. I'm putting the brackets around there to remind us that the k also has the 2 applied to it, because that becomes important. And then, and we also need our coefficient out the front there. And then we have our coefficient, the 2 is now raised to a power of 2 here, and our kx is raised to a power of 3. Now that's the bit we wanted to know about, because that was our question when we were looking at the x to the power of 3. So this is the part that we're really interested in. Now if we read that from our Pascal's triangle, we could see that this one was going to be a 5, this one was going to be a 10, and this one was going to be a 10. If we were putting them into our calculator, we use our NR, where N is our highest power, so the 5 from our question. The R is whatever our power is of our first term. So in this case, we'd have the 5, 4, 3, and then this one here that we're looking at would be a 2. So we can put that into our calculator, NR, and we've got 5, 2. And I'll show you how to do that on the TI-84 pluses. So to do that, we use our, we press our math we go across to probability. We then go down to NCR. So like previously when I learned this at school, instead of using the NR notation, we would use NCR, and that was the number of combinations. So we get that with the 2 boxes there. We can fill them in, the 5 and the 2 that we wanted, and we can see that we get a 10. So we know that that's going to be a 10 there. So what we've got here now is we have 10 times 2 to the power of 3. Oh, sorry, 2. Misread my own writing there. And we've got kx to the power of 3. So when we expand that, we would get 10 times, and 2 squared would be 4. And then here we would apply the 3 to the k. So we would have k to the power of 3, x to the power of 3. That k is a constant, it's a number, so this part here would give us the coefficient of the x to the power of 3 term. Now we know that this part is equal to 1080. So we can say that the 1080 is equal to this. Now 10 times 4 I can work out. So I write 40. Then I have my k to the power of 3. So my first step is to do my 1080 divided by 40. And I get 27 is equal to k to the power of 3. And then I can do the cube root of that, or to the power of 1 on 3, to get k is equal to 3. So now I've solved my k in that. That was all I wanted to do. That was all the question asked for, find the value of k. So I can finish my answer there. Obviously, this is slightly different to the other types of questions where you're finding the coefficient. But if you're finding the coefficient, you would be still doing this step, but instead of solving for the k, you would have a k value and you are solving for the coefficient. Hopefully that's helpful.